Well, good morning, everyone, and welcome to our webinar, Ditch the Wrench, Power Work Holding 101. I'm Allison Jones, the Marketing Manager at Rumheld North America, and I'm delighted to be your moderator today. We have a great program lined up for you where we'll be exploring the world of power work holding and its importance in modern manufacturing. Here's a quick overview of our agenda today. We're going to go through the welcome and introductions, the basics of power work holding and its benefits. We're going to have a lot of great application examples for you today. And then we'll follow up with some question and answers, especially some of you submitted answers when you signed up. So thank you very much. Pro tip, the use cases are numbered. So if you have a question about a particular application, just make sure to note the number when you ask your question. Our speakers today bring a wealth of knowledge and experience to the field of power work holding. Chris Huseman, our Business Development Manager for Power Work Holding here at Rumheld North America. Chris is a seasoned professional with a deep understanding of CNC machining and power work holding. His 20-year journey through the industry has shaped him into an ideal expert to help unravel the pain points of CNC machining. David Vilsek is our Engineering Product Manager for Power Work Holding here at Rumheld. David has 17 years of experience at Rumheld North America with an extensive background in work holding and assembly and handling technology. Just a little housekeeping before we get started. We will be recording the webinar and we will email you a link after today's presentation. If you encounter any technology difficulties during the webinar, please use the chat function and we will assist you. And we encourage you to participate by submitting your questions in the chat box. And we'll answer as many of those as we can during the question and answer session at the end. Without further ado, let's get into the world of power work holding. Chris?
All right, so first off, a little bit about Rumheld North America. Rumheld North America is a joint venture formed between Carlane Manufacturing and Rumheld Group in Germany. Started here in the United States in 1982. Rumheld, however, goes back with a rich history over 300 years. We have two manufacturing facilities, one in Germany, one in Austria. Rumheld is committed to continually researching and developing the power work holding market with unique and innovative solutions. With that, we have over 25,000 innovative solutions in our catalog, ranging from hydraulic cylinders, machining vices, zero-point clamping systems, assembly and handling, power units, all your necessary hydraulic components, pneumatic elements, magnetic clamping, die clamping, press-in devices, drive technology, and as well as full system solutions. So you may be wondering, what is power work holding? Power work holding utilizes hydraulic, pneumatic, or electromechanical clamping systems, typically to hold a part in a machining environment. These systems typically are integrated into a machining center or other manufacturing equipment. It provides quick and repeatable clamping for a robust manufacturing process from a manually loaded all the way up to highly advanced automated solutions. So what are the benefits of power work holding? Increasing productivity, enhanced precision, improved safety, and probably the most significant benefit is the time and cost savings. So who should use power work holding? Do you want to make more parts with the same resources? Do you want to achieve greater repeatability and part quality? Are you looking to have less scrap parts? Are you seeing a shortage of skilled machine operators in your area? Are you looking to improve machine operator safety and ergonomics? If you answered yes to any of these questions, power work holding is something that you should explore. So let's look at the first benefit, increasing productivity by ditching the wrench. It's quick and automated clamping and unclamping. This significant reduction in setup and changeover time, which minimizes idle time, maximizes spindle uptime, as well as assembly time, but allows you to put more parts through a machine, which saves you money. Power work holding systems can operate multiple clamps and other devices in sequence to accomplish a multi-step fixturing task, simplifying the process for the operator. Another benefit is enhanced precision. Consistable and repeatable clamping force ensures accurate and precise positioning of the workpiece. This helps maintain tight tolerances, resulting in higher quality finished products. Significantly reduces the risk of part movement or chatter, which can also result in the ability to push your tools faster. Improves safety, integrated safety features, which help prevent accidental release of workpieces and reduce the risk of operator injuries through check valves, interlocks, and various sensors. Eliminating manual clamping reduces operator fatigue injuries. Power work holding also allows for remote control of inaccessible fixturing. So in a situation where you have features that are hard to reach for a standard operator, or you have a a machine where you want the operator to be locked out, power work holding allows you to accomplish all these things remotely. Operator safety. Moving ahead, we'll quickly look at the operation of a manual fixture versus a hydraulic fixture. This is a very simple illustration here, but it certainly shows the amount of time that it can take to properly tighten a manual fixture in the correct sequence. For every clamping point or supporting point, your operator is required to manually extend or tighten those features, which requires an operator that has the wherewithal to repeatedly do that in the correct sequence to the correct torque. And that's what you're relying on for your part quality. Whereas moving into a hydraulic fixture, since everything is controlled from one point through sequence valves, we can automatically extend part crowding, clamping the part, and extending work supports in the proper sequence in a very short period of time. So that leads us to our time and cost savings. So reducing the dependency on manual labor saves significant time and reduces labor costs. The automation and quick setup capabilities ensure faster production cycles, resulting in higher throughput. So every minute that you save in clamping that part is a minute that you can be machining. It's very easy to show the return on the investment in moving to a system like this because it's such a significant time savings. The precision and stability provided by power work holding can reduce scrap rates and rework, further lowering overall production costs and increasing profits. So just a simple cost justification example showing the prior illustration with a manual fixture, just an estimated cost to produce versus a simple power work holding fixture for the same price. So the first thing that jumps out is the increase in price of around $10,000. But it's very easy to show that through a simple calculation. Most shops tend to know what their hourly rate is that they want to make out of a machine. So as you break down through this list, you can see, the total time to clamp the part versus the machining time, the total cycle time, the number of parts per cycle, and the machining rate per hour. So running through the math there in this specific example, you can see, your return on investment purely in time savings, provided you have the volume of parts to take advantage of that, is very quick, roughly 2 weeks in this case. And we could provide this Excel calculator comment in the chat if you'd like us to send it to you. Very easy way to run the numbers to see if it makes sense to look at moving towards hydraulic work holding versus manual. So some of the pain points that power work holding addresses is a time-consuming setup and changeover, inconsistent clamping forces. When you're relying on an operator to tighten a bolt the same torque every time, even with a torque wrench, there's a lot of variables that still come into play. Safety risks. If the operator doesn't properly clamp and the part is ejected from a fixture during machining, it can pose significant safety risks. Inefficient utilization of labor. If you can reduce the amount of time that a person needs to take to load the part, then you can increase the amount of time they have to perform quality inspections, deburring, or possibly even running a second machine. Lack of adaptability and flexibility, inaccurate positioning and repeatability. When you're tightening with a hydraulic fixture, the cylinder goes to the same place every time. Improves low machine utilization, again, by increasing that spindle uptime. Reduces scrap rates and rework due to the consistency of the process. So let's jump into some power work holding examples. These are some applications that we've been involved in. Most of these are very basic to give some good ideas of moving from a manual process into a introductory clamping situation using hydraulics. So a very basic case here. The customer was literally using C-clamps to hold the parts in a secondary operation and some strap clamps on the top. The manual tightening took a significant amount of time. It relied on an operator that could work through this process consistently. And it was taking the operator roughly 2 minutes to swap parts out. This customer was having issues finding qualified help, finding operators that would use a torque wrench and not over or under tighten the parts. And they wanted to reutilize that existing base fixture or the tool block. So we were able to throw together a quick concept for them using their same setup, using a very simple double acting hydraulic swing clamp. Now it takes the operator less than a minute to swap the parts out. They get consistent clamping force, so no scrap due to over or under tightening of the bolts. So they've increased their throughput and overall increased profitability by making more parts, better parts. Use case number 2, it utilizes some concentric positioning and clamping. So with this part, the customer had prototyped the low volume job, or had prototyped and done the low volume job using just essentially a scroll chuck. Manually tightening, took the operator approximately a minute to swap parts out. This is one where they were having staffing shortages, and this job was getting ready to increase to production volumes, and then wasn't going to fill the need in increasing the throughput. So we used our concentric fixture clamps for this on a 4-axis trunnion. This is a double acting cylinder. So we were able to, with the same amount of load time, change 4 parts at a time and significantly increase the throughput and reduce the scrap. And this is also a system that can now be loading since it's a double acting hydraulic fixture. So this is another example using our flat lever clamps. So the customer was bidding a new high volume job. So we were able to look at this before the job started. They were having staffing shortages, so they wanted to automate this cell as soon as it came to the plant. So our solution for the workpiece clamping was to use our double acting flat lever clamps. These have integrated position monitoring of the clamp arm. So this is tied into the automation system so that as a safety feature before the robot comes in to grab the part, there's verification that the clamps are out of the way. Also verification that the clamps are clamped over the part before the machining cycle starts. This makes for a robust process that's suitable for lights out automated machining. Again, consistent clamp force equals less scrap, shorter load and unload times, and increased throughput. In another use case, customer had a very small part that we needed to get creative on how we clamped this. It was a high volume job, so they wanted to be able to robotically load it. So they needed feedback that the part was present. And a very tight tolerance dictated this part be machined in one setup. So we used our double acting bore clamps with a custom neck length and a custom position of the air seat detection to ensure the part is loaded correctly. And then we added a work support to help prevent chatter. But this setup allows to clamp within the precast board holes, bite in and then pull down into the datum surface. So all the machined features are accomplished in one setup. This was then put into a production environment where they're able to put 4 on a fixture. And this has been a very successful project for the customer. Another example of a more simple fixture using a decoupled pallet, where we're not keeping the hydraulic pump connected at all times. In this case, the customer is manually tightening multiple nuts to clamp the workpiece. Hoisting the parts in place, locating them and clamping them was taking too long to achieve the amount of parts that they needed to make. They were having troubles finding labor, changeover times were too long, and the contract volume was set to increase. So we came up with a simple solution using our double acting hydraulic hinge clamps to hold the workpiece. We located on pins, round and diamond, and roughly a 7-second clamping time. Utilized a pallet decoupler for easy connection to the fixture in the load position. And the benefits of the system included consistent clamping force, no threads for the manual clamps being damaged over time, shorter load and unload times, and it was easier for the operator. Since this was a large part, it was difficult to reach over the part to clamp one side or the other. In another use case here, we see a piston rod being manufactured. The customer had won the job and was using manual clamping at the lower volume, tightening the bolts with an Allen wrench, manually locating the 2 workpieces with a screw and a clamp with 2 bolts. This was his highest production volume job that had gone up in volume, and had a shortage of qualified labor, so he wanted to design a system that would allow him to machine tend this with a robot in the future. I apologize. It looks like the slide is missing for our solution. When we send this presentation out, we will be sure to include that. In a additional use case here, the customer had a leak testing application for a very large cast oil pan. It was very important that the operator tightened those bolts in a proper sequence to ensure that it sealed against the rubber flange before it went to a dunk tank for leak testing. So the pain points, again, were a lot of mechanical clamping. It took a very long amount of time, and it was very easy to get a incorrect test if the clamps were tightened in the wrong sequence and a good seal was not made with the rubber. Oh, okay, I'm sorry. This is the actual application for that prior one. As you can see, we designed a simple fixture utilizing his existing tombstone and just adding fixture subplates, our flat lever clamps. We designed it to be decoupled if needed. And with the flat lever clamp having clamp position monitoring, it enabled him to have the option to automate machine tending in the future. So our solution to that leak testing application was to go with a hydraulic swing or link clamp. This enabled the clamping to all be done simultaneously, ensuring that the part was pulled down into the sealing surface equally at the same time. Using a decoupler, this was able to be loaded at a load station and then moved into a dunk tank as a self-contained unit. So I hope that gives you a good example or a good overview of some introductory applications where you can use power work holding in a simple application that can then lead to, you know, ideally more advanced solutions in the future. I believe we have some user submitted questions after this. We will quickly roll through those and then open the floor up for any additional questions you might have. So generally, how long does it take to deliver a large fixture? So with our robust quick ship line in stock, ready to ship from St. Louis, a turnkey fixture from a builder that we work with can take anywhere from 6 to 12 weeks, sometimes longer, depending on complexity of the fixture, also quantity. Do we have any pneumatic or only hydraulic? Primarily, most of our product is hydraulic. We do have a couple of options in pneumatic, specifically swing clamps. We also have electromechanical swing clamps and some mechanical work holding options. But primarily, our core product and our core focus is hydraulic work holding. Do we sell hydraulic pumps and pneumatic pumps? I'm assuming electric hydraulic pumps or air over oil pumps. Yes, we do. We have a host of options that are built in Germany. We also have 4 different styles of pumps that are assembled in St. Louis that we stock all the components for. Essentially, we talk to you about your application to see what your needs are, and then we assemble or configure that pump specific to your needs at a very competitive price and a very quick lead time because we stock everything in St. Louis. Are there any online videos? Yes, if you go to our YouTube at Romheld North America, there are several videos up there for inspiration and to see certain products. Application evaluations, absolutely. We do free consultations, design concepts, either in person or virtual. Just let us know in the chat if you'd like us to come out, take a look at an application, or if you'd like to jump on a Teams meeting with our application engineers. Either way, we'll connect you with the right people. Do we have smart clamping? Absolutely. So as you move into the world of automation, more data feedback is more and more important. So we have very broad catalog of clamps that have both position sensing, stroke measuring, and sometimes even part presence detection. How do I find a qualified local fixture builder? Please just contact us offline to take a look at your application. We work with many builders, and we can always direct you to somebody that's either local to you or fits your needs, whether it's a lead time need or an application that better suits one builder or the other. So absolutely, please reach out to us, and we will connect you with somebody in our network that can definitely take care of you. Space requirements. So again, this is something that really depends on the product you're looking at. But I will say that we at Romheld have some of the most compact clamping elements on the market. With our high pressure items, we have some very, very unique designs that allow for a very small footprint with a very high amount of clamping capacity that can lead to very small footprints. Our concentric fixture clamp, it operates kind of like a hydraulic vise, except it's very small. So for those small part applications, that's a good compact item. But we also have clamps that go up, as big as you could possibly need. So that question really depends on your application. So please reach out if you have a specific application in mind, and we can take a look at it. So with that, we'll open the floor up to any questions, any specific applications you're struggling with that you might want to discuss. David Vilsek is also on the call, and he will be joining me to field questions here.
Down, so I put the hand up thing. I use vices, manual vices, and I was wondering if Romheld had something for doing plate specifically that I could configure on a T-slot table.
I'm confident we would definitely have a solution. Let's talk further offline so I can get a better idea of what your actual application is. But we have We have a full line of vices ranging from manual up through hydraulic. You know, there's a lot of different solutions we could look at for. It sounds like maybe large plate machining.
Yeah, high mix, low volume.
Yeah, absolutely. Let's connect after this, and I can, you know, get a better idea of what type of products you're looking at or that you machine, and you know, make a recommendation.
Thank you.
Looks like we still have a lot of people on, so if there's any more questions, whether simple or complex, we're happy to field them. So the advantages of a Stark system, oh, where'd they go? So advantage of a Stark system against an FCS type system. So if you're referring to FCS from the manual perspective, you know, a Stark 0-point system, they're really two different types of products. We would be looking at an automated system versus a manual system. But the big advantages of the Stark 0-point system are the active pull-in force versus most competitor systems are simply locking on the retention knob. So creates an extremely rigid connection that's very, very accurate. Jared, yes, this presentation is being recorded. So Allison will be sending this out to all of the attendees afterwards.
Great. Well, thank you so much, everyone, for your time. And thank you, Chris, for getting through that quickly and giving us a little bit back to get our day started. So the webinar recording will go out via email, so be on the lookout for that. The webinar will also be available on demand. So if you want to reference it later or share it with your colleagues, you can also share the on-demand webinar. And Daryl, we'll make sure to reach out. Thank you so much, everyone, and have a great day.